Welcome to the High-Resolution Marine Meteorological Observation and Forecasting strand of the MARI Spoke. This spoke has evolved into high-resolution atmospheric composition observation and forecasting, which helped develop increased collaboration with researchers in RA5 and RA6. This element of the spoke focuses on observing and assessing atmospheric composition impacts on climate and air pollution. In terms of Phase 2, the spoke directly contributes to Global Challenge 2, climate action. In particular, we will develop research in the area of short-lived climate forcers that both impact on climate and health, for example highly complex carbonaceous particulate matter, and, importantly, where there is high potential for rapid co-benefit solutions in related policy development. The short period of time in which short-lived climate pollutants can be removed from the atmosphere presents an opportunity for quick, coordinated action to address global warming over the near term. Widespread and fast action to reduce short-lived climate pollutant emissions has the potential to reduce the amount of warming that would occur over the next few decades by as much as 0.6 degrees Celsius, as seen in the graphic on mitigation pathways. In Phase 2, we also broaden the environments studied from Northeast Atlantic marine air to span the cleanest air on the planet, for example, over the Southern Ocean and Antarctica, to the most polluted, for example, Chinese megacities, where we have strong collaborative links. We keep our feet firmly on the ocean, which appears black from space, leading to a high radiative budget impact even for the thinnest of haze and cloud layers. This illustrated in the ship track graphic, where injection of ship pollution plumes produce brighter clouds, manifesting in ship tracks. We also highlight the links with the SFI data analytics and smart cities, which will become a bigger component of the center going forward. Research excellence is highlighted through the awards of the PI. Research Breakthrough 3 found that sea salt controls the activity of sulfate nuclei, leading to deviations from monotonicity, and are likely to have a greater impact and control of marine clouds on climate, which has significant implications for both basic climate air pollution and geoengineering communities. This is important since generally the availability of cloud nuclei is thought to monotonically increase cloud top reflectance in marine stratiform clouds. The nuclei are thought to be dominated by sulfate. However, while this may be the case, we found that sea salt actually controls the activity of sulfate, leading to deviations from monotonicity, and are likely to have a greater impact and control of marine cloud brightness on climate. Sea spray regulates sulfate cloud droplet activation over oceans, was published last year in Nature's Climate and Atmospheric Science, along with 11 news articles. It adds to a related publication in Nature a year before elucidating the enhancement of droplet formation from surfactants. Currently, that paper, of Vadneved et al., has more than 120 citations and more than 8,000 downloads after 2 years. This year we made a further breakthrough, again in the topic of sulfate and sea salt cloud nuclei and their relative importance to marine cloud brightening and climate. Although sea spray has the highest cloud condensation nuclei activation potential, the majority of its population, residing in submicron sizes, are often obscured by other non-sea spray nuclei, generating challenges in their characterization and quantification. Recent approaches to quantify the submicron sea spray employed a monomodal log-normal analysis to characterize what we would regard as a multimodal distribution. See upper right graph for multimodal distribution. This approach depicts the global oceanic nuclei population comprising less than 30% sea spray, since it cannot capture 3 out of 4 of the modes, where each mode represents a formation mechanism. In our study, we derived sea spray distributions from unique 5-year dataset of aerosol microphysics plus hygroscopicity over Atlantic waters. Hygroscopicity is a measure of water uptake by the nuclei in an increasing humidity field. This approach utilizes the distinctive ultra-high hygroscopicity signature of inorganic sea salt, and is able to identify the submicron sea spray down to 35 nanometers diameter with high time and size resolution. In stark contrast to previous studies, the hygroscopicity-coupled multimodal fitting analysis yields sea spray and sea spray nucleus as much as 500% in excess of estimates produced using the monomodal approach. Our results suggest the contribution of sea spray to global nuclei is significantly underestimated, generally by 60 to 70% and as high as 500% in hotspots. This work was published this week in Nature Geoscience. Air pollution, air quality and climate forcing double whammy from domestic firelighters. Our research achievements in air pollution and short-term climate forcers focuses on the deployment of a national network of advanced aerosol, or particulate matter, Measurements following our initial advances, which reported disproportionate contributions of residential solid fuel to extreme air pollution. Renewable biomass plays a crucial role in transitioning towards climate-friendly heating sources, however, not without its collateral damage in terms of the disproportionately high effects on local air quality. The associated proliferation of residential heating appliances around the world, including developed regions like Europe, where an estimated 70 million are housed, does not appear to be abating. Here, we identify super-self-concentrating pollution events whereby solid fuel residential heating haze is infused with a hitherto unaccounted for firelighter smoke that contributes additional adsorbing black carbon. This black carbon organic aerosol combination results in a strong positive radiative forcing, 149 Wm2, and alters the boundary layer thermodynamics sufficiently so as to further suppress pollutant dilution and dispersion, leading to extraordinary high submicron particulate matter, PM1, 166 micrograms M3. Unfortunately, there is no silver lining in this cloud until the promotion of solid biomass fires with firelighters for ignition is replaced by co-benefit policy. This work was submitted to Nature Energy.